discuss about classful addressing. So classful addressing is basically, how we classify the entire 32-bit into different blocks. So we have already discussed there is something called host address, there is something called there is something called host portion, there is something called network portion in address, in a host IP address. So here we'll come and discuss that there are some golden rules. First, in network bits are the one which is unique. For example, there are first 8-bit first octet is there in is actually network bit. So if there are 1000 PC in a network, for each and every PC that first 8-bit need to be common, first 8-bit need to be same. So that's what network bit, and remaining host bit need to be varying. For example, if I am talking about last 8-bit that's last octet is actually host bit, and if it is varying, so what we can get is 2 to the power 8 number of host, not exactly 2 to the power 8, because the golden rule says all host bit cannot set to 0, all host bit cannot set to 1. If all host bit is actually set to 0, it's called network address, and when all host bits set to 1, it is actually called broadcast address. So barring these two numbers, these two addresses, will be getting IP address. So always, if I am having n number of host bit, the valid IP addresses will be 2 to the power n minus 2. So depending on that, we will be designing the network. So initially, how to identify how many bits are there in network, how many bits are there in host, we need to calculate subnet mask. Subnet mask is the one which is actually telling me how many bits are there in network, how many bits are there in host. For example, if I am having 16 bits there in network, 16 bits there in host, first 16 bit will set to 1 and remaining 16 bit will set to 0. That is how we calculate. Now the entire 32-bit block, 2 to the power 32-bit entire 2 to the power 32-bit number block is divided into 5 classes. Class A, class B, class C, class D, class E. So how to identify each and every class? We actually look into the first, we have to look into the first octet. So if we look into the first octet, we can actually identify, what is, which class it belongs to. So if it is class A, the first 8-bit will start with 0. The first bit of first 8-bit will be 0. So we will be getting a range of 1 to 127. If it is class B, it will be 10. We will be getting a, and remaining all this first 2 bit will be fixed 10. So that is, first octet will be varying from 128 to 191. That is how we can actually get the numbers, different classes. So A will start from 1 to 127. If it is starting from 1 to 127 in first octet, it is class A. Class B 128 to 191. Class C, that's 110. That's class C. It's varying from 192 to 223. Then in class D, when we talk about class D, it is the pattern is 1110. That is 224 to 239. Then we are having class E, the remaining one. The first 4-bit of first octet is set to 1, then 240 to 255. Now class D is actually multicasting, so we will not use class D addressing. Class E used for some experimental and subnet masking and some research purpose. So we will discuss that. So what is the classification? In class A, first 8-bit is first octet is network portion, remaining 24-bit is host. In class B, 16-bit host, 16-bit network. In class C, 24-bit is there in network and remaining 8-bit there in host. So we need to calculate default subnet mask, setting host bit to 0 and remaining network bit to 1 and vice versa. So we get default subnet mask for A 255 remaining all 0, for B 255 and 0.0, and class C last octet will be 0 and remaining all are 255. So that is how we can actually get different subnet mask of different classes. So number of possible networks and hosts are actually calculated. So this is the number of possible hosts and subnetworks are there. Number of possible hosts means you can see in class A 7 bits are varying, so 2 to the power 7, that's number of networks we can design. So fixing first 2 bit, we can see in class B 14 bits are varying, so 2 to the power 14, that many networks we can design, and 2 to the power 16 minus 2, that many hosts we can design in each and every network. And in class B we are having wide range of networks, that is first 3 bit is fixed, so 2 to the power 21 number of networks we can design, and we can have each and every network 2 to the power 8 minus 254 number of hosts. So that is the one when we classify, we have something called reserve addresses. So this is what valid host addresses. So valid host addresses in that particular range, it is saying this is used for unicasting. Basically we'll discuss what is unicasting, broadcasting and multicasting. Class D is used for multicasting and class E is some experimental purpose. So that's the total range of host addresses. We can calculate multicast addresses. Now in this addressing scheme, something called reserve addresses. So we can see starting with 0 is again reserved address, starting with 110.27 in the first octet, reserved addresses. So other than reserved addresses and other than private addresses, we have something called public addresses. Public addresses are the one which we can sell. So we need to understand the concept of public and private addresses. So private addresses, each and every class A, class B, class C in a network, some range is reserved. You can see these ranges are reserved for private addresses. So that's we are discussing what is class A block. Class A block, these are the characteristics of class A block, these are the characteristics of class B and class C blocks. So class based system got some limitations, that's why we move to classless addressing. So classless addressing, we have something called CIDR notation, that's class full interdomain routing, that CIDR full form is. So CIDR notation is classless interdomain routing, and it's a classless notation. We'll now discuss about classless notation. So we'll discuss about also what is network address, what is broadcast address, and then unicasting, multicasting and all. So we will, before we go to this unicasting and broadcasting, we will show, we'll demonstrate how to calculate network host and broadcast addresses of each and every subnetting. So here we are just taking a pause and we'll move to